Welcome to this presentation on the application of the Hartree method to unsteady open channel flow. The Hartree method is a relatively simple numerical integration of the character system of equations using fixed time on spatial intervals for unsteady open channel flow. The Hartree method is an explicit method. With the Hartree method, it is assumed that the flow property at a time step n-1 are known, and we deduce the flow property at the next time step, using forward and backward characteristics as illustrated here. The location of the point L on R at the time step n-1 are unknown because they do not coincide with the grid points. The celerity and their velocity must be interpolated linearly. During the linear interpolation, the time step must satisfy two conditions, commonly referred to as Courant condition or Courant-Friedrichs-Lewy condition or CFL condition, where C is the celerity of a small disturbance in the open channel. The Courant condition is necessary for the stability of explicit finite difference methods, while the stability of implicit finite difference scheme is superior. Explicit schemes such as the Hartree method have other advantages, including a greater accuracy with less computational efforts. This was recently shown for the numerical modeling of negative surges. Using the Hartree method, the flow property at the next time step are calculated as a function of the previous time step. And at each boundary, one flow condition is set by the boundary condition and the other is calculated using either the forward or backward characteristic. At the next time step, n+1, the same process is repeated, as illustrated here. For subcritical flow motion, the discretization of the characteristic system of equation gives the flow property at the point m in terms of the velocity and the celerity. The flow properties at point L and R may be linearly interpolated between points A and B and points B and C. A simple numerical implementation was proposed, starting first by calculating the location of the point L and R using the characteristic slopes based upon the flow property at point B. Then the value of the velocity and celerity are calculated by linear interpolations, and the characteristic sum of equation is then applied. The process is iterated by calculating the slope of the characteristic line using the value of the celerity and velocity at the point L and R, and the process is repeated until a desired level of convergence is achieved. The Hartree method is named after the English physicist Douglas Hartree, who was a professor at Cambridge. The scheme is sometimes referred to as the Hartree-Fock method after a Russian physicist. The Seventh equation, the characteristic system of equation, and the Hartree method are basic concepts for the numerical modeling of unsteady open channel flow and its practical application including flood modeling. These are discussed in the relevant YouTube video movies in the same YouTube channel.